Hello everyone, myself Devita Singh, Assistant Professor, School of Computer Applications, BVD University. Today we'll discuss Big Data Architecture Patterns. Hi everyone, today we'll be discussing two important Big Data Architecture patterns, namely Lambda and Kappa architecture, along with their variants. And finally we'll compare these two. So let's get started. So we have the layers which are remain constant for all the patterns. These layers are data sources, data storage, big data governance, and data consumption. I have explained these in my big data video. Please do check out there. And now we will discuss this Lambda architecture. So a Lambda pattern has both batch and real-time processing. It can actually be considered as a combination of two systems. On the other hand, Kappa architecture is an adoption which has increased rapidly over the past years and eliminates the needs of batch altogether by focusing on real-time processings. We'll begin discussing with the three Lambda architecture patterns. First variant will be the batch serving layer. In this, there is a batch layer which ingests data and computes values, followed by a dedicated serving layer to where computed outputs of the batch layer are written. The consumption layer reads from the serving layer. Like discussed earlier, a Lambda architecture is a combination of batch and real-time processing. The real-time processing enables via what is known as speed layer. So in the first variant, the speed layer ingests, computes, and produces output to be directly utilized by the consumption layer. The second variant of the Lambda is what we are calling a dedicated serving layer. Here, just like serving layer for batch, there is a dedicated serving layer for a speed layer. So the final Lambda pattern variant is common serving layer, which combines both layers of batch and speed into one common layer which caters to consumption layer. Now let's discuss Kappa pattern. Here the real-time processing is done using a stream layer which outputs is computed to value a dedicated serving layer. This output is then used by consumption layer. As you can see, the batch processing is eliminated in Kappa architecture. Now we'll discuss Lambda versus Kappa architecture, which are the key differences in between these both patterns. When it comes to adoption from a traditional or legacy system, Lambda architecture is easy to adopt as most of the ETS can be used for ETL modules, even used as it is a batch processing side of things. So on the other hand, a Kappa architecture would require a system to be built ground up, most likely using a new text altogether. That's what also makes a Lambda architecture easier to implement in Kappa. Now, when it comes to maintenance, a system built on Lambda architecture is not easy to maintain as you are basically maintaining two different systems. That is, one from batch processing and the other one from real time. On the other hand, system built on Kappa architecture is relatively easier to maintain. And when it comes to performance, Lambda architecture performs quite better. This is because it has access to complete data and has the capability and time to optimize various Kappa architecture which is entirely on stream processing. So Kappa architecture has many challenges like event duplication, sequencing and etc. which can reduces its performance. So when it comes to the resource code duplication and use cases, then we found that the CPU memory etc. a system built on Lambda architecture requires more resources than in comparison to Kappa architecture. Next factor is to compare a code duplication. Since Lambda architecture is works in both batch and stream, so it is very lightly. So in Kappa architecture, the duplicacy is very nominal in Kappa architecture. And finally, when we talk about the use case, the lambda is used when there is a requirement to retain the data, typically for regulatory or analytically purpose. On the other hand, kappa architecture is well suited for typically online data or a trusted data sources which are available online. So this is the basic difference between lambda and architecture, and this is all about this video. Thank you.